Hi, in this video we are discussing the 12th numerical from the exercise for the chapter Units and Measurements, which is the first chapter for 11th standard physics. So let's get started. Now question में हमें कुछ physical quantities बताई गई है of a cylinder and हमें उन quantities के measurements भी है. तो सबसे पहले हमें जो है length of the cylinder दिया गया है and the measurement of this length is 4.00 plus minus 0.001 centimeters, where plus minus 0.001 is the absolute error in length. Similarly, second quantity जो हमें दी गया है that is the radius of the cylinder, जिसका measurement है 0.0250 plus minus 0.001 centimeter, where plus minus 0.001 is the absolute error in radius. इसके अलावा थर्ड क्वांटिटी हमें दिया गया है दैट इज द मास ऑफ द सिलेंडर एंड दिस मास मेजर्स एज 6.25 plus minus 0.01 where plus minus 0.01 is the absolute error in mass, and these measurements are done in the units gram. Using all these physical quantities, we have to calculate the percentage error involved in the determination of the density of the cylinder. So I'll just repeat कि हमें cylinder की density नहीं calculate करना है, हमें percentage error calculate करना है when we are calculating the density of the cylinder. So the question is about percentage error and not about density. And now that we have discussed our question, let's move on to the solution of this particular numerical. सबसे पहले हम लिखेंगे all the given data that's been given to us in our given section. So I'll prepare our given section, and the first quantity जो हमें दी गई है that is the length of the cylinder. So let me quickly write length, and this is given to us in the format L plus minus delta L, as we have seen, where L is the mean value and this is the absolute error involved in length. ठीक है, so इसी फॉर्मेट में हमें जो है हमारे measurements दिए गए हैं where L is 4.00 and the absolute error in length is plus minus 0.001 and the measurements are done in centimeters. Similarly, हमारी जो second quantity है that is the radius of the cylinder, and this radius is also given to us in a similar format, that is R plus minus delta R, which is the absolute error in radius, and the measurement is 0.0250 plus minus 0.001. Again, the measurements are done in centimeters. And the third and the final quantity is the mass of the cylinder, which is also expressed to us in a similar format, that is M plus minus delta M, where M is the mean value of the mass and plus minus delta M is the absolute error in the measurement of the mass, and इनके measurements है 6.25 plus minus 0.01 and the units are grams. Apart from this, हमें जो है question में और कुछ given data है नहीं. So now let's move on to the next section of our numerical, that is the to find section, जहाँ पर हम लिखेंगे all the quantities which we are required to calculate or find. So इस particular question में हमें एक ही चीज़ calculate या find करनी है, and that is to calculate the percentage error in the calculation of density of cylinder. So percentage error in density of our given cylinder. So I'll write percentage error in density. Now let us try to figure out what sort of formulas we can use to calculate this percentage error in our formula section. So let's prepare our formula section and let us discuss the formulas. Okay, so सबसे पहले हमारा जो main goal है that is to calculate the percentage error in density. So the formula to calculate percentage error in density, so I'll just write it using a separate ink. So in density, so this formula is, first we need to find the relative error in density. So relative error in density, which we represent as delta rho upon rho, if rho is the letter to represent density. So relative error in density multiplied by 100. So before we calculate the percentage error in density, our task is to calculate the relative error in density. So let us first try to figure out what this relative error in density would be like. So now let us calculate or find the formula to calculate relative error in density. So relative error in density is defined as delta rho upon rho, and it comes from the formula of density. So density का formula, that is rho is equal to mass divided by volume. So ये हमारा density का formula है, बड़ा ही common formula है. इस formula से अगर हमें relative error in density ढूंढना होगा, let me just mention density over here so that we don't confuse it. And so from this formula, the relative error in density is the addition of relative error in mass, represented as delta m upon m, where delta m is the absolute error in mass and m is the mean value of mass, plus the relative error in volume. So relative error in volume is delta v upon v. Now अगर if we notice relative error in mass कैलकुलेट करना easy है because delta m और m का वैल्यू हमें given है, but relative error in volume calculate करना अभी difficult है because we have no idea about the volume of the cylinder. So before we calculate the relative error in density, it's important for us to calculate the relative error in the volume of this cylinder. So our first task now becomes to calculate the relative error for the volume of the cylinder. So volume का relative error ढूंढना है, and as per the definition, relative error in volume, that is delta v upon v, comes from the formula of the volume. So volume of a cylinder is equal to pi into r square into the length of the cylinder. So इस formula से relative error in cylinder would be 2 times the relative error in r, so that is 2 into relative error in r, that is delta r upon r, plus 1 times the relative error in length, so that is just delta l upon l. So these are the formulas to calculate the relative percentage error. So our first job is to calculate the relative error in volume using the formula delta v is equal to 2 times delta r upon r plus delta l upon l. Then calculate the relative error in density using the given formula, and finally calculate the percentage error using the relative error in density. So now that we have understood all the formulas that we are going to use, let us try to solve this equation in our solution section. Okay, so in our solution section, we'll solve the numerical. And okay, so the first step हम जो करेंगे solution में is to calculate the relative error in the volume. So as per the formula, relative error in volume is defined as delta v upon v, whose value is given to us as 2 into the relative error in r, which is delta r, that is 0.001, divided by the mean value, that is the r, which is 0.0250. So this is the relative error in r. So let me just mark it as this is our delta r upon r, and plus we have to calculate the relative error in length. So that will be delta l, whose value is 0.001, divided by the value of l. So that is the mean value in length, which is 4.00. So 4.00, and this over here is the relative error in our length. So delta l upon l. Okay, now if we were to solve these terms further, we would get our first term as 0.008 and our second term as 0.000025. And if we were to add this, we would get our relative error in volume, that is delta v upon v, as 0.08025. And let me mark this as equation 1. Now we need to calculate our relative error in density using the value which we have just found out. So I can say from formula 2, I can calculate the relative error in density. So from formula 2, I can say relative error in density defined as delta rho upon rho. It is the value of relative error of mass. So that is delta m upon m, which is given to us. So the value of delta m is 0.01 divided by the mean, that is 6.25, that is m, plus the value of delta v upon v, which we have just calculated it to be 0.08025. So this is from equation 1 and given values. Okay, so we have simply substituted the values in the formulas for relative error. So if we were to solve this further, our first term simplifies as 0.0016 plus 0.08025, and if we were to add this together, we would get the resultant answer as 0.08185, which is the value of relative error in our density. And let me mark this as equation number 2. But our task was not to calculate the relative error in density, but to calculate the percentage error in density. So let us quickly calculate the percentage error in density using the value of relative error in density. So I can make a statement from formula 3. I can say the percentage error in density, percentage error in density can be a value of relative error. So we substitute the value from equation 2, that is 0.8185 into 100 as per the formula. And if we were to solve this, we would get the percentage error in density as 8.185%. So this is the final answer, that is percentage error is 8.185%. And with this, we have solved our numerical. And if you want the PDF of this solution, make sure you check the description. With this, I hope it helped you. Thank you.